All right, the definition of similar polygons. Polygons are similar if all the sides are proportional and all the angles are congruent. Congruent corresponding angles, extended proportion on the corresponding sides. To signify that figures are similar, we just do a little squiggly line in between them. So in this definition right here, we see that ABCD is similar to GHIJ. And remember, the similarity statement will match up the corresponding sides and the corresponding angles by letter order. So that means that A was congruent to G, B was congruent to H, C was congruent to I, D was congruent to J, and that all of these corresponding side lengths are proportional. So you can represent the side lengths in what's called an extended proportion. That's where you set all the sides over their corresponding side, and those will all be equal. Usually, if you're trying to decide what goes in the top and what goes in the bottom, it's left to right, or congruency statement to congruency statement, or if one is underneath the other, it's top to bottom. If they don't tell you, then it's just your best guess, and neither one of them would be wrong, like the one I've got on the next slide. So in this particular situation, I compared these two triangles, and AB was corresponding with XY, so 15 over 6, BC and YZ, 20 over 8, and AC and XZ, 25 over 10. When you reduce all of these fractions, it will reduce to 5 halves. So because they all reduce to the exact same number, 5 to 2, that lets me know that they're proportional, and that's an extended proportion. By the way, that number that all of the sides reduce to is called the scale factor. So if you need to identify the scale factor, it's what any corresponding pair of sides reduce to. Okay? So here's a triangle. Now, if I go ahead and tell you that these two triangles are similar, how would you compute the scale factor from the bigger triangle to the smaller triangle? Well, 9.8, 4.9, I could make that into a fraction. 9.6 and 4.8, I could make that into a fraction. But you only need one fraction to determine the scale factor because they're all going to be the same. So let's look at the one that's the easiest, the one that doesn't have decimals in it. I would have used 10 to 5, which would reduce to a scale factor of 2 to 1. Does everybody see how we determine scale factor? All right. Understanding similarity, when I say that things are similar, you ought to be able to pick out all the corresponding angles and set them congruent. So in this case, that would be angle M congruent to angle S. Why did I pair M and S up? Well, they look to be the same angle here, but also they're the first letter. Angle N would go with angle R. Anybody want to take a stab at what angle P is congruent to? Angle T. And then the extended proportion for the ratios of the sides, once again, I just look at the lettering of the similarity statement. MN over SR, NP over RT, and MP over ST. And you just set them all equal to each other. Does anybody have any questions about how to do that? All right, let's let you do one. All right, from the solution here, you can see I just paired everything together. D went with H, E went with J, F went with K, and G went with L. And the first two go with the first two. The first and the last go with the first and the last. That's how you finish out your polygon, is the first and last letters will always be pairs too in side lengths. Any questions? All right. So if you want to determine if things are similar, you have to check. And to check, you need to compare all of the corresponding angles and make sure they're congruent, and all of the sides, corresponding sides, and make sure they are, starts with a P, proportional. All right, so in this case, I can look and see that all the angles got marked congruent. So that works. So let's start taking a look at sides. So JK corresponds with what? TU. And that should equal KL corresponds with what? UV. So that looks a little bit fishy right there. Let me just check for those. So JK is 12, TU is 6, KL is 24, UV is 16. Does 12 over 6 equal 24 over 16? This is 2, but this is not 2. Those are not equal. So since they're not equal, the figures are not similar. Down here, if we look at these, and you got to be careful, what angle does A correspond with? Nope. D. 2 archymarchies, 2 archymarchies. So that means AB would correspond with DE. And that means BC would correspond with EF, and that means that AC would correspond with DF. So what I got to do is I got to check and see if all of those are equal. I hope they are. Let's see. 12 over 15 equals 16 over 20 equals 8 over 10. So what I would do is I would go through and I would reduce all of these fractions. 3 will go into both of those numbers, so that reduces to 4/5. When I divide these by 4, that reduces to 4/5. When I divide those by 4, that reduces by 4/5. So the scale factor is what they reduce to, which is 4 or 5. So 8 divided by 4 is, 8 divided by 2 is 4, and 10 divided by 2 is 5. And when I divide 2 into 8/10, I get 4/5. I misspoke. My apologies. All right, and 4/5 is your scale factor. So to write the similarity statement, it would be triangle ABC similar to triangle DEF. Because A matches with D, B matches with E, and C matches with F. And then the scale factor is equal to 4 to 5. Everybody okay? All right. So tell me whether or not these two are similar. All right, in part A, what two sides did you compare? KL with what? Okay, so just because KL is on the top and WX is on the top does not mean that that's the best sides to compare. Because the longest side in this rectangle is 15, and the longest side in this rectangle is 20. So really, I should be comparing KL with XY. And I should see if that's equal to KN compared with WX. It turns out they're not. So that would be 10 over 15. And 10 over 15 does not equal 15 over 20. One is 3/4 and one is 2/3. But you need to make sure that you're at least setting it up right. Does that make sense? So these are not similar. Here, all the angles match. And so these little slanted lines are going to compare with these other slanted lines, 12 to 6. And the straight lines, the horizontal and vertical lines, are all 18 to 9. So if I just do that proportion right there, that covers the whole problem. Are they the same? Yep, we have a winner. This reduces to 2 to 1, and this reduces to 2 to 1, which is equal. Therefore, our similarity statement is going to be, I'll do A, B, C, D, E. For the first one, what is the matching corresponding letters in the second one. What does A correspond to? S. What does B correspond to? R. So it's going to go SRVUT. Be very careful about it, because if you put something wrong on the test, I'll mark it wrong.
So is the scale factor 2/1?
Yep, the scale factor can be written as 2-to-1. In terms of a fraction, you could write it like that. You could write it with the word 2 separating the two numerals. Everybody okay? All right. Let's ramp it up a little bit. We're going to use the fact that these two polygons are similar, and we're going to solve for the value of x. So I know I've got a smaller and a larger version. The larger version is listed first. The smaller version is listed second. So if I were just looking at x, what side do you think corresponds with x? BC. And what's the value of BC? So BC corresponds with FG. So that would be 7.5 over x. Notice I put it in the same order that it was written there. Do we have something that we could compare that to? We know the figures are similar. So that's going to equal something. Do we have any other sides we could compare that would give me numbers in both the top and the bottom? A, B. Did you say A, B as in boy? A, B, and EF are not both numbers. DA and DE are. So we could say 9 over 6, because AD has to be proportional to ED. So now we've only got one variable. Reed, if we had done what you said, we would have two variables, and those are hard to solve unless you have two equations. Here we only have one equation, so we only want one variable. So I'm going to cross multiply, and that's going to give me 9x is equal to 45. So divide both sides by 9, and we find out that x is equal to what? Sure, why not? So 7.5 over 5 is the same thing as 9 over 6. I'm okay with that. Y'all use this picture right here. It's actually the same one, and solve for y. Set this up and solve for y. All right, so hopefully what you did was you set 9 over 6. Remember, the bigger one over the smaller one, because the bigger quadrilateral came first, is equal to 5 over y. A lot of times people get confused and they flip the second one because they always want their variable to be in the top. Be careful about that. Cross multiply and you get 9y is equal to 30. So y will equal 30 over 9, which is, I can divide both of those by 3. So that's going to be 10/3. Is everybody okay with that? 10/3 or 3 1/3, not 3.33. Uh-oh, Caroline, what's the matter?
I don't know. Like, why would it be 9 over 6 equals 5?
Okay, because over here it listed the A, B, C, D one first, so I put it in the top. So the big one, the number goes in the top, and then the little one, the number goes in the bottom. So when I'm setting up this one, I put the big one in the top and the little one in the bottom. That's the 9 over 6. And then it should be proportional to these two corresponding sides. Big one in the top, little one in the bottom. Does that make sense?
So this side and this side are proportional?
Yeah, so this side right here goes with this side and the little one. And then this flat side right here goes with this one. And the comparison of those two sides is equal in a similar figure, or proportional. All right, here's where it gets tricky. So your class is making a rectangular poster for a rally. The poster design is 6 inches high by 10 inches wide. So somebody drew it out on a piece of paper, and their design was 6 by 10 inches. The space allowed for the poster is 4 by 8. So we have to determine what's the largest we can enlarge this 6 by 10 to so that it will still fit into a 4 by 8. How many people are thinking the first thing we're probably going to have to do is convert to some inches? Good, because that's the first thing we got to do is convert to some inches. So the first thing I'm going to do is I'm going to take 4 feet and I'm going to convert 4 feet to inches. Well, I want the feet to cancel out, so feet in the bottom, inches in the top. There's 12 inches in 1 foot. Hopefully this helps you keep your conversion whether you're supposed to be multiplying or dividing. That gives me 48 inches. If I do the same for 8 feet, it's 8 feet over 12 inches compared with 1 foot, or times 12 inches over 1 foot. Once again, the feet cancel. 8 times 12, 96 inches. Now, the question is, which one of these is less in terms of these measurements? Well, the 48 matched the height. And the 96 matched the wide. Let me put that down here. Wide 96. So what I'm going to do is I'm going to divide both of these values by their corresponding amounts. Whichever number is smaller is what's going to limit the size of my figure. So if I divide 48 by 6, is that bigger or smaller than 96 divided by 10? Well, 48 divided by 6 is what? 8. And 96 divided by 10 is what? Yeah, that's right, 9.6. So which one of these is the smaller? So this scale factor right here is the more limiting scale factor. The biggest thing I can do with this poster is scale it up by a factor of 8. I can't scale it up by a factor of 9.6 because then it won't fit on the height part. It'll fit exactly on the wide part, but then it wouldn't fit on the height part. If I scale it up by 8, it's going to fit exactly on the height part and be shorter than the wide part, but that's okay. I can be shorter and not longer. So now all I need to do is take 6 and multiply it by the scale factor, which is 8. And I can take the other one, which is 10, and multiply it by the scale factor of 8. And that means I'm going to have a 48-inch by 80-inch poster. And if you want to, you can go ahead and change that back to feet. So changing it back to feet, it's 4 feet by 12 will go into 80 6 times. And then the remainder was 8. So it'll be a 4 foot by 6 foot, 8-inch poster. Everybody okay with that? So like I said, the first thing you have to do is you have to analyze which one got scaled smaller. Did the height get scaled smaller or did the width get scaled smaller? And you do that by a division problem. Then once you find what the smallest scale is, that's your scale factor for the whole problem. Yeah.
So to decide which one is divided by which number, is it just with the height and then
Right. So the big height got divided by the small height, and that was a scale factor of 8. And the big width got divided by the small width, and that was a scale of 9.6. But we don't want to use this one because it's bigger than that one. This one is what limits us. Let's see if you guys get it. You guys do one. Same poster in problem 4. Our limits are 4 by 8. What's the largest we can do with a 3 by 4? All right, so hopefully you went and did a comparison. You did 4 divided by 3, which the only way I know to write that is 4/3. and 8 divided by 4, which is 2. Which one of these numbers is bigger? 2 or 4/3? 2's bigger, so that's going to be excluded. This will be our limiting factor since it's smaller. So now I need to take the 3 and multiply it by 4/3 to get how tall it will be, and I need to take the 4 and multiply it by 4/3 to get how wide it can be. So that's going to be 4 feet by 16/3 feet, which would be the same thing as 15 feet and 4 inches. So my dimensions are 4 feet by 15 seems a lot. How about 5? How about 5 feet 4 inches? There's your poster dimensions. All right, finally, the last thing I want to talk to you about, ratios are huge when it comes to the standpoint of creating drawings and letting those drawings represent something that you're going to build. So engineers, architects, construction workers, they need to really know about scale drawings. So a scale drawing basically says, I'm going to represent something on paper, but I'm going to tell you what scale factor to multiply it by to do it in real life. So maybe I would go out and the actual scale here is 1 centimeter to 200 meters. So maybe I could take a ruler. Let's see if I can find the ruler. Yeah, I got a ruler. So I would take a ruler that was in centimeters. So is this ruler in centimeters? And I would measure how many centimeters it was from one leg of the bridge to the other. And I'm going to estimate and say that's 9 centimeters. 90 millimeters, which is 9 centimeters. So if my length were 9 centimeters, I would multiply it by that scale factor to get the meters. So how many centimeters are in a meter? Well, in this case, 1 centimeter equals 200 meters. So we can just use the scale factor right there. The centimeters will cancel out, and that bridge is 1,800 meters across from pole to pole. So, I mean, that's just another application of scale that is very relevant to a lot of different areas. Just about anybody at some point is probably going to use scale in doing something, whether it's a project at home or a project for your work or a hobby. All right, tonight's homework. On the pacing guide, I had some numbers after 46, but they don't exist. So your homework ends with problem number 46.